All right, so in this lesson, we will classify numbers, and we're going to use the real number system. So you'll take your other sheet of paper, and let me go to it now. Take this paper out, and we're going to use this, all right? So this is called the real number system. Oops. I don't know what that was supposed to be. All right, real number system. All right, the real number system is a way of like categorizing, classifying like types of numbers, but you'll get what I'm saying. It's easier just to show you, right? So we have two. Think about this as a big box. Big box. This box is made of two kinds of numbers. We have these things called rational numbers. Ooh. Rational numbers. And on this side, these are irrational numbers. Or maybe I should make this a different color. Irrational numbers. If you notice, if we have something in this box, the rational numbers box, it is not in the irrational numbers box. Whatever's over here is not over here. Whatever's over here is not over there, right? So inside of rational numbers, we have these things called integers. Inside of this box, we have something called, now I'm thinking of something else, sorry. Whole numbers. That could look better. And inside of this box, we have something called natural numbers. So I'm going to come down a little bit. Okay. Natural numbers. Numbers. Okay, so this natural numbers box is inside of the whole numbers box, which is inside of the integers box, which is inside of the rational numbers box, which is a real number. So what I'm actually going to do is let's call all these real numbers. Let me get rid of that. These are all real numbers. Yeah, two types of real numbers, rational numbers and irrational numbers. And you have different kinds of rational numbers. You have integers, whole numbers, and natural numbers. If it is a natural number, if it's in this box, that means it's also in this box. So if it's natural, it's also whole. If it's whole, it's also an integer. If it's an integer, it's also rational. If it's rational, it is a real number. And if it's rational, it's not irrational. So, natural numbers. These are counting numbers. I'll put this in a different. These are counting numbers. These are counting numbers. In fact, I don't know why that looks so funky to me. These are counting numbers. So numbers, well, like 1, 2, 3, 4, and so on and so forth. Now, remember, natural numbers are a type of whole number. Whole numbers are going to be your counting numbers. So like 1, 2, 3, 4. And 0. So it would be 0 1, 2, 3, and it keeps going. Okay, not too bad so far. So, for instance, 4 is a natural number. So that means 4 is a whole number. That means 4 is an integer. That means 4 is a rational number. That means 4 is real. Okay? 0 is a whole number, which means it's an integer, which means it's rational, which means it's a real number. But 0 is not a natural number. Okay? Integers are going to be, where's my line? Oh, I'm already on it. Are going to be your whole numbers and negatives. So for instance, 0, 1, 2, 3, but also -1, -2, -3. Example, and then it can keep going either way. So maybe I should do this instead. Maybe I can say that it can be 0, 1, 2, 3, and keep going. And it can be -1, -2, -3, and keep going. So -3 is an integer, which means it's rational, which means it's real. So -2 is an integer. That means it's natural and it's real. It's not irrational. -2 is rational, so it's not irrational. This -2 or this -1, they are not whole numbers. They're not natural numbers. This +2 is actually a whole number, is actually a natural number. Okay? So, rational numbers. This one is going to be numbers that can be written well, and this isn't the perfect way of saying it, but I think it's the way that you understand for now, as fractions. So for instance, like 2 is a rational number because it can be written as 2/1. -3 is a rational number because it can be written as -3/1. But also, you can have things like 2.5 because you can write that one as 3/2. You can have like -0.66 because that's -2/3. So numbers that can be written as fractions. Now these ones are weird because you're like, not all decimals can be written as fractions. Not all decimals can be written as fractions. So any numbers that can be written as fractions, I'm going to say, and repeating decimal. I should probably put this higher. And repeating decimals, because decimals can be repeating decimals. And you know what? I'm going to say numbers that can be written as fractions, which include decimals. Oh my goodness, I'm just going to run out of space. Maybe I can do that. Includes decimals that end or repeat. So numbers that can be written as fractions, these include decimals that end or repeat. So like this decimal ended, 2.5, done, cool. This 0.66 repeated, cool. But if it was like 0.2456, 1, 8, 7, like it just never repeats and it keeps going, it just never ends, then it'll be irrational. So let's give another look at this. So square root of 9 is, because that was just 3, by the way, positive or negative 3 technically. So irrational numbers are numbers, we'll just say for now, numbers, we'll just say decimals that don't end. That'll be a way that a useful way of saying it. Decimals that don't end, such as pi. I hope I can do this better. Pi, because that's 3.14 and then it keeps going. It never ends. The square root of a non-perfect square. So the square root is 7. Because the square root is 7, let me go ahead and do that for you. Square root of 7, for instance. 7 square root. The square root of 7 is 2.645, and then it just keeps going. It just doesn't ever end. Doesn't end. And like that's all you need to know now. Technically, you could say like the square root of like negative number, because that's impossible. You know, for now it's an imaginary, but we won't worry about that one. Cool. So once again, all these numbers are real numbers. There are 2 types of real numbers: rational numbers and irrational numbers. Inside of rational numbers, there are integers, whole numbers, and natural numbers. A natural number is a whole number, is an integer, is a rational number, is a real number. A whole number is an integer, is a rational, and is a real number. An integer is a rational number and a real number. And a rational number is a real number. So all of these natural ones fit in the whole numbers. But all these whole numbers, like 0 doesn't go in here. Like 0 goes this way, but not inside. Like this -3 goes this way, goes up, but not down. This 2.5 is rational, but it's not integer, it's not a whole number, it's not a natural number, but it's a real number. All right, so let's do some problems with this.